Hello everyone, I'm Said and today I will presenting InstructPix2Pix paper. This paper published in 2023 and offer a unique approach to image editing using a human written instruction. To start, let's look at a demo um, that showcases the capability of this model. As you can see, it's just a simple prompt. You can make a wide range of edits to any image. What's especially impressive is that by applying a sequence of a specific prompt, you can guide the model to generate a unique creative transformation. Even after several edits, the final image remains rooted in the original image. This flexibility highlights the power of InstructPix2Pix for initiative interactive image editing. InstructPix2Pix goal is to enable initiative image editing by allowing user to simply write down what they want to change in an image. But unlike traditional models that often need a detailed prompt or even user-drawn mask to guide the edit, this model handles edit directly from instruction without additional specification. However, gathering label data for instruction-based editing is a challenge, which the authors address by using a large pre-trained model to generate the necessary training data. The core approach leverage GPT-3, a language model, and Stable Diffusion, a text-to-image model. GPT-3 generates the necessary variety in instruction, while Stable Diffusion handles generating the corresponding image pairs. This combination effectively provides a large and diverse dataset that allows the diffusion model to generalize edit across various real-world image and instruction. As you can see, by adding some having some instruction like have her ride a dragon, we can have this result. This is very similar to the into the input images. So the data generation begin with GPT-3, creating an instruction based on initial caption. So this change in caption is then used by Stable Diffusion to generate pair images, and Stable Diffusion use prompt to prompt to ensure the images are similar and only differing in specific changes. As you can see, for example, we have two image. The left one is the photo of a cat riding on a bicycle, and the right side is a photo of a cat riding on a car. These images are very similar and a minor changes. So, this is the big picture of the methodology. The model consists two parts, and the first part is generating an image editing dataset, and the second is a training diffusion model on that dataset. They used a fine-tuned GPT-3 to generate instruction and edit caption, then use a Stable Diffusion model in combination with prompt to prompt to generate pair of image from pair of caption. And finally, InstructPix2Pix diffusion model is trained on this dataset. I will go into the detail of this process. At first, GPT-3 model was trained on 700 caption on a Lion dataset, as well as manually created edit instruction and edit caption. For example, for the input caption, we have a cat sitting on the couch. For edit instruction can be a cat wearing a hat, and the final caption will be a cat wearing a hat sitting on a couch. So this is the whole process. Now GPT-3 model is trained. So once the GPT-3 is trained, we only input caption into the model. The model then output edit instruction and the final caption. It's around 450k caption generated this way, which will now be used to train a stable diffusion model. And this data is then used to train the stable diffusion model, which learns from three main elements: the input caption, the edit caption, and the original image. In short, instead of building a complex model from scratch, and they focus on creating a high quality training data. This way, they can train a simpler model more effectively, allowing it to handle complex editing tasks. So, one issue and the model faced was creating very different images, even when the prompt very similar. This happened because the model treated each caption independently, which sometimes led to inconsistent results. So to solve this, the author used a technique called prompt to prompt, which helps keep the image visually similar when the prompts are similar. By using prompt to prompt, the model can refine the output, creating images that stay closer to the original style or content, even with the change in the prompt. As you can see in the pair one, there is a difference between the input and output. But in the pair two, with the prompt to prompt, the output is very similar to input, but a little changes apply. For example, a horse is changed by dinosaurs. One impressive feature of InstructPix2Pix is that it was trained entirely on synthetic data. Both the images and the text instruction it learned from were generated by other AI models like GPT-3 rather than written by real people. So despite of this, the model can generalize surprisingly well to real image and real human written instruction when they test it. The generalization shows how effectively the model has learned to interpret and apply diverse editing instructions. Uh, this outcome highlights the model's robustness and the power of carefully generated synthetic data in building systems that perform well in real-world application. As you can see on the left side, we have an input with instruction make it a grocery store. Then apply the instruction piece to piece. We have the output is very similar to the input, and it's changes to the grocery store. The result is amazing. So to control what the model should focus on, whether it should stick closer to original image or follow the text instruction, they used a technique called classifier free guidance, or CFG. We have two key sitting here, ST and SI. ST for text guidance and SI for image guidance. ST pushes the model to align more with the text instruction, and SI keep the output similar to the input image. By adjusting these two, we can control how strong the edit is versus how much it keeps from the original image. So this lets the model make more precise and controlled edit. As you can see in the picture, when we increased ST from 3 to 15, it's going to similar the prompt, cyborg, and with increasing the SI from 1 to 1.6, it's going to similar to the first image, the sculpture. So, in terms of comparison, the author compare InstructPix2Pix with two popular models, STEdit and the prompt-to-prompt. STEdit makes edit by adding noise based on new prompt, while prompt-to-prompt modify embedding to match prompts. InstructPix2Pix perform better in terms of balancing similarity to the input image and accuracy in following the edit instruction, as shown in both quantitative metric and visual example. As you can see in the image, the higher is better, and as you can see, the blue one is showing the InstructPix2Pix, and the InstructPix2Pix outperformed STEdit and prompt-to-prompt model. Also, in terms of qualitative comparison, we can see example of different image editing approaches, including STEdit, text-to-life, prompt-to-prompt, and InstructPix2Pix. Each method has been applied to the same image, but there is a key difference in how they interpret the instruction. While STEdit, text-to-life, and prompt-to-prompt rely on output captions to describe the desired final image, InstructPix2Pix follow specific edit instruction directly. This allows InstructPix2Pix to make more precise and flexible edit based on exactly what the user wants, rather than rely on general image description. So this approach makes InstructPix2Pix more intuitive and powerful for guided image editing tasks. As you can see, we have the same image for all models, and the output is very different, and it shows that the InstructPix2Pix performance is very good in terms of quality. The one advantage of InstructPix2Pix is speed and the flexibility for iterative editing. Each edit happens in a single pass, so high resolution image can be edited in under 10 seconds. This make it ideal for tasks where multiple edits are needed in a sequence, like changing the season or adding object in the landscape. For example, as you can see in the first part, we insert a train. In the second, we insert a thunderstorm. And in the third, we turn the image into the oil pastel drawing. And in the final, we convert the image into the dark, creepy vibe. So this sequence is very interesting because you can do it very fast. It's a very efficient way. Um, like many AI models, InstructPix2Pix inherit biases from its training data. For example, GPT-3 might produce a text that reflects common stereotypes, such as associating certain profession with specific genders. These biases can carry over into generated images, which is known limitation of the model trained on large pre-existing dataset. Um, as you can see, we have some input, and after that we have instruction make them like flight attendants. Uh, but it cannot go. The result is not very good because the model is biased because the flight attendants are mostly a woman, and the model cannot figure out one of the person is man and the other one is woman. Uh, Also, this model has another weaknesses. It has some failure cases, such as it cannot do structural changes like zooming into the image or move it to the Mars or color the type blue or have the people swap places. Um, I think Um, the, the most of this limitation is actually the limitation of data. So we can improve this by improving the data, and this limitation also exists on other related works. Um, to wrap up, there are a few key takeaways from this work. First, by teaching image generation models to follow direct instruction, we can make them much more flexible and useful in real-world application. Instead of creating complex new models, the author focused on generating high-quality training data using existing pre-trained models like GPT-3 and Stable Diffusion. So this approach allowed them to build a model that can handle complex edit through a simple prompt. InstructPix2Pix shows us the power of the good training data. When we have a strong data set, even a straightforward model can produce impressive results. So this method opens up a new possibility for creating interactive instruction-based tools that are initiative and user-friendly. Thank you very much. If you have any question, please ask me.